Hello, and welcome to this tutorial on interest rates and inflation risk. In this session, we'll look at how inflation and how inflation uncertainty affects the real return on investments and the cost of borrowing. Let's start by thinking about what is inflation. Suppose we have various items in our economy: bread, apples, taxi fare, rent, representing a broad basket of goods and services that we're measuring. And we look at the price today of these items. So the price of bread might be $1 per loaf. The price of apples might be 50 cents per pound. Taxi fare to downtown from some location might be $2. The rent for a one-bedroom apartment in a particular location might be $150 per month. So we would need to define these very specifically. And we look at how the price changes over some period of time, let's say a year. So in our example here, the price of bread has gone from $1 to $1.10, a 10% increase. The price of apples has gone from 50 cents per pound to 57 cents per pound, a 14% increase, and so on. We see the percent change in the prices or costs of each of these items. So is this inflation? What about this? Let's say the prices move in different directions. So the price of bread might go up slightly, up 1%, but the price of apples might go down 6%. The price of taxi fare might go up. The price of rent might go up by a smaller amount. Is that inflation? Well, in each case, we would need to define sort of a quantity of the items and look at them in aggregate. So in the first case, the price of all of these items and more, let's say the basket cost $500 in a month. So these might be items that a typical consumer would spend living in a particular city. And then a year from today, that exact same basket of goods and services might cost $550. So using this definition, we would say, well, the general price level has gone up by 10%, even though individual items may have gone up by more or less than that amount. Then we look at the second case where we had different moves, some up and down, and they might balance out so that the basket might actually still cost $500 after a year, although the cost of individual items could be more or less. In this case, we would say inflation was 0%. So now let's think about how it affects savings and investment. Suppose a consumer saves $500 and invests it at an interest rate of 8% per annum. So the account balance started out at $500. At 8%, they'll earn $40. That's 8% of 500 is 40. So they'll have $540 in 1 year, or an 8% increase in the amount in their balance. Now let's say the inflation was 10%. So the cost of this consumer's basket went from $500 to $550. So we could look at this as we could say, well, when the consumer made the decision to save the $500, to put it aside, they deferred the consumption. So they didn't consume that basket. And they basically deferred an amount that would have bought 100% of that basket. A year from today, they have 8% more, but the basket costs 10% more. So how much basket could they consume? Well, they actually could consume less. Even though they have more money, because the cost of the basket is higher, they could only consume 98.18% of that basket. So in percentage terms, they've actually lost 1.82% in terms of purchasing power, the 100 minus the 98.18. Now, let's suppose the rate of interest were higher, 12% per annum. Well, in that case, they end up with 560 instead of 540. And so now, instead of being able to consume less, they can consume more, because since 560 is greater than 550, they actually can consume 101.82% of a basket, or 1.82% more. Now, suppose we were expecting the 10% inflation, but inflation unexpectedly turned out to be 15%. So in that case, the consumer basket actually goes up to 575. And so that's a percent change of 15%, reflecting the inflation. And as you can see in this case, even though the consumer was expecting to come out ahead, they end up coming out behind, or rather the saver. So the saver will be able to buy 97.39% of a basket in that case, which represents a 2.1% decline. So let's introduce some concepts. Nominal versus real interest rates. So nominal interest rates are the rates that we earn on money. It's a rate per annum paid on a unit of currency. We were looking at dollars, but it could be any unit of currency. For example, as we saw, if the nominal rate was 10%, then $100 would become $110 a year, including the interest. But if inflation were also 10%, that 110 would buy the same as $100 did the year before. So in this case, we'd say the real return is 0%. So we need another way of thinking about this, a real interest rate. And that's basically the rate paid per annum in terms of goods and services. So it represents basically the increase or decrease as a result of the investment in terms of consumer purchasing power. And the real interest rate, if the interest rate is contractual, the nominal payment will be adjusted for actual inflation. And we'll see some examples of this. And an expected real interest rate, however, is just the real return obtained if the actual inflation equals the expected. So hopefully these concepts will become clear as we move on. So let's consider a problem. Suppose the nominal interest rate is 5% and the expected inflation is 3%. What is the expected real interest rate? Well, there's a quick and dirty, easy way to get the approximate answer. We can just subtract 3% from 5%. And when rates are low, like they are here, this is often what people will do. They'll just say, okay, that implies a real return of 2%. But there's actually a more precise way of looking at it, which won't matter a lot when rates were low, but could matter a lot when rates are higher. So this is the required, what is required in 1 year to purchase what $1 can purchase today. So the way we think about it is as follows. If we had $1 and 3% inflation, then a year from now, it would cost us $1.03 to buy what $1 could buy today. So the nominal value of $1 investment in 1 year, in our example, is 5%. So we have 105. So 105, but the cost of our basket is 103. So the gain in purchasing power is the real interest rate. So that would be 105 divided by 103 minus 1. So rounded to 2 decimal places, that would say the real rate is 1.94, a little bit less than 2%. Now, let's see how much higher rates of inflation can affect our approximation. So the approximation here would be 35% minus 25%, nominal return of 35%, and expected inflation of 25%. But if we do the precise calculation, we see that $1 today, to buy what $1 can buy today, we need $1.25. And the nominal value of our investment has gone up by 30%, so we'll have $1.35 in a year. But when we compare these two, 135 over 125, we see actually there's been only an 8% increase in what we can buy. So having invested at 35%, we're able to buy 8% more a year from now, not 10%, so significantly below. Now let's consider what happens if inflation is lower or higher than expected. So let's return to the previous case where we have a 5% nominal rate. But suppose actual inflation was not 3%, but was 1% or 7%. What would be the real return in that case? And let's consider who would benefit in each case, the borrower or the lender. So let's look at the first, where inflation is unexpectedly low. So here we're looking at where we expected 3% inflation. So that presumably was why the nominal rate was 5%, but inflation turned out to be 1%. So the real return, 1.05 minus 1 divided by 1.01 is 3.96%, considerably higher than the 1.94% we saw on the previous slide that was expected based on a 3% inflation. So in this case, the lender benefits, the saver. So they're getting a higher increase in purchasing power than they expected. They were expecting inflation to basically reduce purchasing power by 3%, and it only reduced it by 1%. So as a result, they have a 2.02% net gain in purchasing power versus expectations. But their gain, well, let's consider now what would happen if actual inflation were higher. So inflation were 7%. The real return here would be negative, right? So they end up with 105, but the cost of the basket is 107. So they end up losing 1.87% in purchasing power versus a plus 1.94% in the expected case. So here the borrower benefits, paying 3.81% less in real terms. So you can see that the unanticipated inflation will hurt either the lender and help the borrower, or vice versa, depending on which direction it goes. Now, if expected inflation changes, so before it actually is realized, there's an increase in the expected inflation, that has a different effect. So suppose the expected rate of inflation increased from 3% to 7%. 5% nominal return now is going to give us a negative real return. So if we wanted to have the same real return as we had with 3% expected inflation, what would the nominal return have to become? Well, we can do a quick and dirty, and this is always useful to do to get order of magnitude of what the new number would look like. So we were expecting, would have expected to have a nominal return of 5%. The expected rate of inflation has gone up by 4%. So to be roughly equal, the new nominal return or nominal rate would need to be 4% higher as well, so 9%. How would the exact calculation work? Well, recall that the real return before was 1.05 divided by 1.03 minus 1, or 1.94%. So we need to basically get that same real return on, not on 1.05, but on 1.07. So we multiply our 1.07 times 1.0194, subtract 1, and we get now 9.08%. So what this is saying is 9.08% would give us an expected real return of 1.94 if inflation were 7%. And you can do this in one step without the intermediate rounding. So you just take 1.07 times this here represents 1 plus the real return, and you'll also get the 9.08%. So if the real interest rate is set contractually, we get a different analysis. So suppose the loan or bond says, you know what, we don't want to have to worry about what the actual rate of inflation is. Let's just commit to paying a 1.94% real. What will the nominal rate of realized be if inflation turns out to be 3%? So this is different than the previous problems. Before, we were contractually committing to a nominal rate, and here we're contractually committing to a real rate. Okay? So the approximate answer is we just say, all right, 1.94% real. If inflation is 3%, we can just add that and we get 4.94% nominal. So what that's saying is if we committed to 1.94% real and the realized actual rate of inflation were 3, we would expect a return about this. But as you might expect, the actual precise is going to be a little bit different. We would effectively compound the two numbers. So 1 plus the real rate times 1 plus the inflation minus 1 gives us the nominal return of 5%. Okay? And the reason for that is because we would be earning that real rate on 1 plus the rate of inflation. Now, suppose we're looking at this example further and we say, what is the implied break-even rate of inflation if the contractual real rate were 1.94%? And we could alternatively set it in nominal terms of 5%. So the problem here is we're offered a choice. We can have 1.94% real contractually set or 5% nominal contractually set. And the difference between these two reflects an anticipated or break-even rate of inflation. So the approximate answer is you'd say, well, 5% nominal minus 1.94% real is 3.06% expected inflation or break-even inflation. The precise answer would do it on a compounded basis. So we'd look at 1.05 divided by 1 plus the contractual rate, subtract 1, and we get 3%. Okay, so they're close, but again, in each case, there will be differences. And clearly, as these numbers get bigger, then this difference will get larger. So let's summarize how this works. These calculations essentially are reflecting what's called the Fisher effect. And what we've been doing is we've been saying 1 plus the nominal rate is equal to 1 plus the real rate times 1 plus the expected inflation rate. And this is the basic relationship between nominal rates and real rates on a compounded basis. And then we can rearrange these formulas to solve for any one of these variables. So if we were rearranged to solve for R, we would get this, R plus expected inflation plus this compounded, right? And of course, when R and expected inflation are small, this is very small. And that's why for small rates of inflation, people often ignore it. Real rate of interest, again, would be reflected in using our nomenclature, small r, and this would be the formula for that, just rearranging that one. And then the expected break-even rate of inflation would be the nominal rate minus the real rate divided by 1 plus the real rate. And again, so if R is very small, then this is going to be close to 1, and so the arithmetic approximation will be close. So if we look at our examples or illustration numbers, you can see how this all relates. So 1.05 is equal to 1 plus the real rate times 1 plus the inflation. Or if we looked at it in terms of nominal rates, 1.94% plus 3%, and then this is that extra term. Solving for the real rate here, we get our 1.94% back, and solving for the expected break-even inflation. So if you had any doubts about that, you might want to pause here and look at this, or go back and look at the slides later to make sure you understand how the compounding of this works, and when and where you might use an approximation. So that's it. Thank you for listening.